Hey there, Geometry. Thanks for tuning in for another episode of Math with Mullins. Today we're looking at 9.7 Day 2, the Law of Sines and Cosines. We're still going to be using what we learned in Day 1, which was Law of Sines. So if you need to know what that is, go back and check out 9.7 Day 1. But now we're going to bring in what is the Law of Cosines and how do I apply it. So the Law of Cosines can help us solve triangles as well. We specifically do Law of Cosines when we're just given maybe one or two sides and 1 degree angle measurement or when we're just giving the side measurements. And these are the ways that we're going to do that. So if I have triangle ABC, where A is an angle and across from that is the A side length, B is an angle, across from that is B side length, and C is an angle, across from that is a C side length, then the following options are true. I can take A squared and set that equal to B squared plus C squared minus 2 times B times C times the cosine of A. And then the same thing would be true for the rest of those. So make sure you write this down on your theorem sheet. These are just good hints for you to try when you do the law of cosines. This will be available to you on your test as long as you have it on your theorem sheet. So let's pause the video here, write these down, and then when you're ready to go on, click play. So like before, we're just going to do one triangle at a time. So what I'm going to do here is kind of ignore this one first, try this one, and then we'll reveal that one next. So solve the triangle around decimal answers to the nearest 10. What I first like to do is I like to go ahead and label my A side, my B side, and my C side. So that's really going to help me fill in some blanks here. And because I am given B's angle, it'll be best to use the B squared statement here, okay? So that means I'm going to say B squared is equal to A squared, which is 45 squared, plus C squared, which is 43 squared. Whoops. Okay, and then minus 2 times AC, so 2 times 45 times 43, and then all that times the cosine of angle B, okay? The cosine of angle B is going to be 88 degrees, so I'm also going to fill that in right there too. Next, we're just going to simplify what we've got. So 45 squared, I calculated all these ahead of time, so you might want to double check these with your calculator. I did it just to save some time and energy here. So we've got 2025 plus 1849 minus 3,870 times the cosine of 88, okay? Next, I'm going to add these two things together. So 2025 plus 1849 is going to give me 3,874 minus 3,870 cosine of 88. This is where you want to think about your PEMDAS rules, okay? So to solve for B squared, this is technically multiplying. So we're going to multiply cosine of 88 with 3,870 and then subtract that number from 3,874. So I'm going to take the cosine of 88 times that by 3,870, and I'm going to get this 135.06, and then subtract that from the 3,874. So 3,874 minus 135.06, I'm going to get this B squared is equal to this 3738.94 if I round that. And then to find my answer here, I'm just going to take the square root of this. So B is approximately, to the nearest tenth, 61.1. Okay, now that we have that, so that was step 1, we can use that with our law of sines. So step 2 would be using the law of sines, because now I have the sine of 88 degrees over 61.1 can be equal to whatever we choose. Maybe we do sine of A, so sine of A over 45. You could also do sine of C over 43. You would still get the same answer, but for C, and then you just use that to find letter A. Here we're just going to do the same thing we did yesterday. Start by cross multiplying. 61.1 times the sine of A will give me 45 times the sine of 88. Okay, the sine of A can be found then by taking 45 sine of 88 degrees, dividing that by 61.1, and because we are looking for whatever A is equal to, we can find out what A is by taking the inverse of sine of this entire expression, 45 sine of 88 over 61.1, and that will give us A rounded to the nearest tenth, 47.4 degrees. Okay, so then our final step here, because A now is 47.4 degrees, I know what B is, now I just gotta find my angle C. So I just take 180 minus that 88 degrees from B, minus the 47.4 degrees from A, and I'll get C, which would be 44.6 degrees. Okay, so we found all things that were missing here, the side length of B and A's and C's angle measurements. Okay, here's what I'm going to have you do now. See if you can try this one over here, doing the same thing we tried together. Okay, notice you're given A's angle, so what I would recommend is using the statement that starts with A squared. So A squared is equal to B squared. Let's go ahead and label here as well. B, C, little a. B squared, 23 squared plus 26 squared minus 2 times 23 times 26 times the cosine of 114, which is the letter A. We're going to go ahead and calculate a few things here. So 23 squared is 529, 26 squared 676, minus 1,196 cosine of 114. Okay, that'll give us, remember we're doing multiplication first and then subtracting that from my addition. So that'll be 1205 minus, we got 486. Oh, this is one thing we need to point out. When you do the cosine of 114, you're going to get a negative number, and then when you times that by 1,196, you still get a negative number. So this is negative 486.46. So notice this is 1205 minus negative, which means you're adding those. So A squared is now equal to 1691.46, and then we find the square root of that to find out what A is. A is approximately 41.1. Okay, so that was step one. Step two, we can now use the law of sines. I'll go over here for that. So the sine of 114 over 41.1 can be, let's do sine of B over 23. Again, you could choose to do sine of C here, it wouldn't matter. 41.1 times the sine of B is equal to 23 times the sine of 114. So the sine of B can be found by taking 23 times the sine of 114 degrees divided by 41.1. Since we don't know what B is, B then can be found by taking the inverse of sine times this expression, 23 times the sine of 114 degrees all over 41.1. That is going to give you B is equal to about 30.7 rounded. Okay, once we know that, here's 30.7. We can do our final step, which is to take all of our angles. So 180 minus 114 minus 30.7 degrees gives us the leftover amount of 35.3 degrees, and that is the angle C. Okay. Next up, we're going to look at some triangles where you're just given the sides and you have no angle measurements. Understand this is also for regular triangles. This is not right triangles. So we'll start off maybe the same way, except now we can fill in a lot more things. In this case, I'll just start with, here's my A, here's my B, here's my C, and I'll use my A squared statement. So that means 4 squared is equal to 6 squared plus 5 squared minus 2 times 6 times 5 to find the cosine of A. Okay, so that'll be 16 equals 36 plus 25 minus 60 cosine of A, which would give me 16 is equal to 61 minus 60 times the cosine of A. In order to get cosine by itself, I'm going to subtract this 61. So this is negative 45 is equal to negative 60 cosine of A. And then I'm going to divide both sides by negative 60. So cosine of A can be found by taking negative 45 over 60, which I'm seeing that as 3/4, okay? Which then means A can be the inverse cosine of 45/60 or 3/4. So you're going to type that into your calculator, or 0.75 inverse cosine. You're going to get A is about 41.4 degrees. Okay? Now that we know that, here's 41.4, I can now use my law of sines. So the sine of 41.4 over 4 is equal to, I'm just going to do sine of B over 6. So I'm going to have 4 times the sine of B is equal to 6 times the sine of 41.4. Sine of B then is equal to 6 times the sine of 41.4 degrees, all divided by 4. So in order to find B, I'm going to take the inverse of sine, and this expression, 6 times the sine of 41.4 over 4. And I'm going to get B is about, let's see, I'm going to double check this one, 41.4 times sine times 6 divided by 4, and then inverse sine, 80.42. So 41.4 sine times 6 divided by 4. 82.7, there we go. So B is 82.7 degrees. So now, here's my 82.7 degrees. I'm just going to use all of my degrees to find C. So step 3, 180 minus 41.4 minus 82.7. I'm going to get about 55.9 degrees for letter C. Okay, so again, I'm going to have you try this next one here on your own, see what you can try. Starting with your A squared statement. Okay, so here is A, here is B, here is C. So statement 1, A squared, 23 squared is equal to 27 squared plus 16 squared minus 2 times 27 times 16. Then that'll help me find the cosine of A. Okay, 23 squared is 529, 27 squared is 729, 16 squared is 256, minus 2 times 27 times 16 is 864, cosine of A. Okay, a lot of this is just making sure you're putting things together correctly. 529 is equal to 985 minus 864 cosine of A. Then I'm going to subtract 985 from both sides. So I'm going to get negative 456 is equal to negative 864 cosine of A. To find the cosine of A, I can have negative 456 over negative 864. Okay, which eventually is just going to change those to positives, right? So A can be found by the inverse cosine of 456 over 864. So A is equal to, I'm getting around 58.1 degrees. So up here at A, I'm going to write 58.1. So now I can use my law of sines to start that. So the sine of 58.1 over 23 is equal to the sine of B over 27. Cross multiply. I'm going to have 23 sine of B is equal to 27 sine of 58.1 degrees. Sine of B can be found by taking 27 sine of 58.1 degrees and dividing all that by that 23. So B can be found by the inverse sine of this entire expression here. Okay, when you type that in, B is going to be equal to about 85.3. So my final step is step 3. Start with your 180, subtract your 58.1 and your 85.3. We're going to come up to about 36.6 degrees for angle C. Okay. Last thing, and then we're going to kind of review all of chapter 9's big basic triangle things. In this case, it's asking you to find the angle for B. So I would start with the B squared statement. Here is B, this one is A, and this one is C. So 316 squared is equal to 155 squared plus 197 squared minus 2 times 155, 197 to find the cosine of B. Big old numbers. 99,856 is equal to 24,025 plus 38,809 minus 61,070 cosine of B. Let's add some things together. 99,856 is equal to 62,834 minus 61,070 for the cosine of B. I'm going to subtract these two items here to get 37,022 is equal to negative 61,070 cosine of B. Then I can find the cosine of B by having 37,022 divided by negative 61,070 for cosine of B, which means B can be found by finding the cosine inverse of 37,022 over negative 61,070, and that's giving me about 127.3 degrees. So this statement was saying an organism's step angle can be measured by is a measure of walking efficiency. So the closer to 180, the more efficiently the organism is when walking. This is a dinosaur, probably a large dinosaur, and you can tell because it's a little bit closer to 180, it's more efficiently walking, whereas if it was not as close to 180, it wouldn't be as efficient. Okay. All right, just to recap everything. So what to use to solve a triangle and when. We're going to use this with Pythagorean theorem when we have a right triangle and you have two sides. The triangle sum theorem can be any triangle, and you have to have two angles. So that's like angle A plus angle B is equal to angle C, or angle A plus B plus C should be equal to 180 degrees. Sine you can only use when there's a right triangle. So you need one acute angle, its opposite, and hypotenuse. Cosine, also right triangle, using that one acute angle, and cosine is adjacent and hypotenuse. Tangent is also a right triangle, one acute angle, where you have its opposite and adjacent. Okay. The law of sines can be any triangle. You have your pair of angles and a side. Okay. Then for your law of cosines, you can also use any triangle, but you don't have angles and sides. Don't have, a pair. So like angle A and side A, or angle C and side C. Okay? That's going to conclude our lesson on 9.7 day 2, law of sines and cosines. Hopefully this was helpful for you, and give it a thumbs up if it helped you. We'll catch you next time when we take a big review of chapter 9, just in time for our chapter 8 test. Or chapter 9 test, Have a great day.